Building a 555 IC timer circuit. First, power the circuit with batteries. The components required for the circuit are 2 resistors, 555 IC, LED light to display the output, the switch, the capacitor. Note that there is a negative side to the capacitor. This can be distinguished by the grey side on the capacitor or the shorter pin. The negative side should be connected to the side on the green circuit board where the capacitor symbol is shaded. Lastly, the potentiometer, used to vary the resistance. The potentiometer is represented by the R symbol on the circuit board. Turn on the switch. The lighted LED indicates that the circuit is properly connected. Now, let's explore the circuit. Increase the resistance by adjusting the potentiometer. See that the LED starts to blink. Let's examine how the blinking occurs. When the switch is on, the current flows through the capacitor and charges it. When this happens, the LED does not light up because no current is flowing through it. When the capacitor is fully charged, it discharges itself, allowing current to flow through the 555 IC, the resistor, then through the LED to light it up, as shown. The resistor here serves as a protection to prevent large current from damaging the LED. The 555 IC serves as a timer, which sets the blinking frequency of the circuit. Recall that each time the LED lights up is due to the discharging of the capacitor. The continuous charging and discharging results to the blinking. Note that by adjusting the potentiometer, it is also setting the 555 IC timer to a certain duration which determines the blinking frequency. Now, we increase the resistance further. Notice that the frequency of the blink decreases. If you increase the resistance even more, the blinking gets even slower. When R increases, current decreases. Therefore, it takes longer time to charge up the capacitor. This results to a slower rate of charging and discharging of the capacitor, causing LED to blink slower. Blinking frequency is dependent on the duration set by the 555 IC timer to discharge the capacitor. Besides adjusting the potentiometer to vary the duration, changing the size of capacitor can set the blinking frequency. Let's look at how this works. Here are some capacitors of different sizes and value. Pay attention to the shorter pin as it indicates the negative side of a capacitor. This is important during circuit connection. The leftmost is the smallest size capacitor of 10 microfarad. The middle one is 47 microfarad. And the rightmost is the larger capacitor of 1000 microfarad. Let's experiment using these 3 capacitors and examine the effect of them on the LED. Using the same circuit as before, it's important to set a fixed timer duration by fixing the resistance of the potentiometer for the subsequent experiment. The capacitor here is the medium one for the 7 microfarad. Pay attention to the frequency of the blink here. Now, change to a smaller capacitor of 10 microfarad. You will observe a faster blinking compared to the previous circuit. The blinking frequency increased. Next, change to a larger capacitor of 1000 microfarad. You will observe a much slower blink as compared to the previous 2 experiments. The blink frequency decreased drastically. Now, let's summarize. The size or value of the capacitor is directly proportionate to the time taken to charge up the capacitor. Hope you have a better understanding for 555 IC circuit. Thank you.